Hello everyone, welcome to my channel. So in the last video we talked about the basics of executor service and the various ways that we can create a thread pool, and we discussed in detail about the fixed thread pool. So let's take a quick recap of how a fixed thread pool works. So as you can see here, I've defined a new fixed thread pool here with core pool size of 10 threads. And then this is my student service, which accepts a student object, and then it sleeps for about 100 seconds. This is just for the sake of example, I gave it as 100 seconds. And after that, it returns a UUID for the student. We give a looping through about 100 students in here, and then we just submit it with the executor service. Now if you run this in debug mode, what you would see is that so if you look into the executor service here, there are 10 worker threads because that is the maximum size that you define here. And if you look into the queue size is 90. It is backed by a linked blocking queue. So what this means is that if your pool size is 10, and if any new tasks come in, and if all your threads are busy, then those tasks, they wait in the work queue here. That's the linked blocking queue. And once if any of the threads complete with their existing task, they pick up the next task from this queue in the first in first out order. So this is how a fixed thread pool works. Now going back, in this video we are going to look into how a new cached thread pool works and how it differs from a new fixed thread pool. So let's look into some basics of this one. So for the new cached thread pool, you cannot define a core pool size. So core pool size is basically 0, and the maximum pool size is integer.max value. So what this means is that it does not limit you on how many worker threads that you can create. If you keep pumping it with n number of tasks, it will create n number of threads for you. The only constraint would be imposed at the system level, like defined by your how much of a CPU you have and how many threads it can create, etc. Now the keep alive time for the thread is 60 seconds. So this means if you spin up a new thread after it finishes a task, the executor service keeps it alive for a maximum of 60 seconds, and after that it tears it down. Then if a new task comes in, and if a thread is sitting idle, then that thread picks up the task. But if all the threads are busy, then a new thread would be created and the new task would be handed over to that new thread. It is backed by a synchronous queue. So basically it is like a handoff queue. It doesn't have any capacity to hold any tasks. When you submit a task to a synchronous queue, it blocks you until someone is ready to consume that task. So basically it blocks you until a thread is ready to consume that task that you have submitted. And it is best suited for short-lived tasks, as you can imagine, because there's no restriction on the number of threads that you can create. So you cannot block these threads for a long amount of time because you would start running out of threads soon. And the policy, the rejection execution handler, the policy that uses is the abort policy. So basically it means after it reaches a point where it cannot accept any more tasks, it would reject any new tasks that come in. Right. Now let's see how we can see this in an example. So yeah, we just have to replace the new fixed thread pool here with a new cached thread pool. As you can see, it does not accept any parameters, so you cannot define any core pool size here. And now if you run this in debug mode, so what you should see is that there should be 100 threads created without any of them waiting. So now let's take a look. So as you can see, the queue is the synchronous queue with the size of 0. See the number of threads that it created. It created 100 threads for you. So there's no limit on the number of threads that you can create. So this is what we discussed on the slides. And the keep alive time is 60 seconds. So after a thread finishes its task, if a new task doesn't come in within 60 seconds, then the executor service would tear down that thread. So yeah, that's simple, cached thread pool. So depending on the use case, you have to pick either a fixed thread pool or a cached thread pool, right? Now, the next one that we are going to talk about is a single-threaded executor. As the name suggests, the core pool size and the maximum pool size is 1. So basically there is always just one thread. And it is blocked by a linked blocking queue, which is similar to a fixed thread pool executor, right? And queue size is unlimited. So basically if your worker thread, the single worker thread that you have, if it is busy, then any new task that comes in, it has to wait in a queue. And once the thread is finishes its current task, then it would pick up the next task from the queue. And of course the tasks are executed sequentially. Now let's see how we can use this one. So this is again pretty simple. You just have to replace this with new single-threaded executor. If you run this again with the same example, so you would see that you just have one worker thread, and your queue, which is a linked blocking queue, it has 99 tasks waiting in it, because your single worker thread, it is busy and it is waiting, because if you see our sleep time is 100 seconds, right? So it is waiting for that to finish. So now you might be wondering, like, what is the difference between having a single threaded executor or why can't we just replace this with a new fixed thread pool of size 1, right? So basically it's the same, isn't it? So the only difference is, I mean, you'd still get the same functionality whether you use a fixed thread pool of size 1 or a single threaded executor. The only difference is whatever this returns, you can still this new fixed thread pool returns. So you can typecast this into let's say thread pool executor. So you can typecast this to a thread pool executor, and then once after you get back that, you can still set the core pool size if you want to. You can update the core pool size if you want to. But you cannot do this for a single threaded executor. That's the only difference between a fixed thread pool of size 1 versus a single threaded executor. Right? And now the last one that we are going to discuss in this video is the new scheduled thread pool. So this is like a cron job. Like if you want to start a thread, and then if you wanted to execute a certain tasks for every X number of seconds, then you would probably go with a new scheduled thread pool. So you can specify a core pool size, and the max pool size is again integer.max value here. So let's see how we can put this into an example. So you can say new schedule thread pool size. So let's give a core pool size of 1, just for sake of it. So this we can replace with the scheduled executor service. get rid of this one. Now what we can do is we can just say ExecutorService dot. So you have examples here like schedule with a fixed delay or schedule at a fixed rate. So let's take this simple example of scheduling at a fixed rate. So what it takes is a runnable command. So what do you want to run for every X number of seconds? Let's just print something, okay? We'll say system.out println hello. And what is the initial delay? So how long it should wait before it kicks off the first run. So let's keep it 5. And how often do you want it to run? Maybe every 2. And then last one is the time unit. Like, do you want it for every 2 days or 2 seconds or 2 hours, whatever it is. So in this example, let's take it 2 seconds. So what this means is that, so kick off this job after 5 seconds and repeatedly run this statement for every 2 seconds, right? So let's comment this out. Let's comment this whole thing out in here. Now if you run this, so as you can see, this is the initial delay of 5 seconds, and after that for every 2 seconds it keeps printing the statement that you have defined in here. So if you have any job, like if you want to constantly download some files from somewhere for every 1 hour or any scheduled amount of time, or if you want to save certain records to database or push some logs to a third party to your Kibana stack or whatever, I mean, you can define that job in here using scheduled executor service. So that is all I have for you in this video. So we have talked about the various ways that we can create a thread pool, fixed thread pool, cached thread pool, single threaded executor, and also a scheduled thread pool. You can also create a custom executor service. So basically you would define your core pool size, your maximum size, and what is your rejection execution handler be like, and all that. So you can define your custom executor service as well. So that's all I have, guys. So in the next video we are going to talk about a fork join pool and see how that differs from whatever we have discussed so far. I hope you liked this video. Please leave any suggestions or comments, and if you like it, please share and subscribe to my channel. Thank you.